Welcome back, my pre-calculus students. So, cool thing, ellipses have like basically two centers. They're called foci, kind of like the parabolas did. Very exciting stuff. So just be careful that you're looking at the correct equation for them. So an ellipse looks a lot like a circle equation. The big difference is that it's going to equal 1 all the time, and it's going to be divided by two different numbers, okay? Key things, foci, basically tether around your ellipse. They're equidistant. Excuse me. Whoa, sorry. Okay. So anyway, the distance always adds up to the same value no matter what. So if, say I went from here and I wanted to go there to there, that distance is the same added as the other one. All right, key stuff. Major axis. Our major axis is the long way across. So if it's a horizontal ellipse, then it's going to be horizontal. That means the minor axis would be your vertical. And then if it's a vertical, oh, that was terrible. Sorry. If it's a vertical ellipse, it's going to be your major axis is this way, your minor axis is that way. Hopefully that makes sense because it's shorter. The other kind of cool thing is that any point around your ellipse basically gives you what looks like the Pythagorean theorem distance-wise between your foci, your center, and a point on your ellipse. Notice that your minor axis is 2b, because there's a b there and then there'll be a b there. The distance between your center and one of your foci is c. So c equals center to 1 focus. Okay, plural is foci. All right. Then your a value is your distance from your center to one edge along your major axis. So your major axis is 2a, always, okay? So the best thing to notice about your two equations is that your major axis value, which is 2a, switches. So if you have a horizontal major axis, aka a horizontal ellipse, you have a first, okay? So because it's along your x-axis, hopefully that makes sense. The x is there, so your major axis goes underneath. When you have a vertical major axis, aka a vertical ellipse, notice your a is now under the y value because now your y is going to be longer. It's a vertical ellipse, okay? I know these are a lot of new words for us, but it's going to be a lot easier when they all come together, okay? So, some major things here. Really the shortcuts for us. Your horizontal foci, okay? So writing the coordinates, giving a simplified radical. When graphing, use decimals. Your horizontal foci, easiest way to remember this is going to be h plus or minus c, comma, k. And if you think about it, it should make sense because remember your center is still h comma k, no matter what way it's going. But this time you add c, and I told you before that your focus is literally a distance of c from your center. So hopefully that makes sense. And then your vertical one is going to be the same thing, except now your center is going vertically, or your axes are going vertically. Okay, so now it's h comma k plus or minus c. So make sure you're filling that into your notes as well as your formula sheet, because that'll actually be handy later when you guys have a quiz on it. All right, next up. Let's do a little bit of practice. All right, so write the coordinates for the center and the foci. So the first thing I want you to notice is whether this is a horizontal or a vertical ellipse. Easiest way to tell, a squared is here, b squared is here. How do I know? A is always bigger because it's your major axis. Okay, so if the 25 was underneath the y, you know that's bigger, that means that's your a. So automatically a squared equals 25, so a equals 5. If b squared equals 4, b equals 2, awesome, and your center Notice that both of those values are squared for x plus 4 squared and y minus 3 squared. So your center is -4, +3. Same attributes as our other graphs. Also, I don't know why that says eggs. It really should say EXS for examples. That's Mrs. Sullivan's writing there. Okay, so it says write the coordinates for the center and the foci. We already have our center. Now we need our foci. So if it's a horizontal ellipse, remember your foci are just your H plus or minus C, comma K. Now, we need to figure out C. What's kind of cool is that there's a relationship between A, B, and C from your front page that you may have noticed. It looks a lot like the Pythagorean theorem, except the relationship is actually A squared equals B squared plus C squared. So under your relationship part of ellipse, not like your relationship, but like the relationship of the ellipse, notice that it's going to be A squared equals B squared plus C squared. So just be careful there. So that means that A squared is 25. We already have that. B squared is 4. And then we need plus C squared. So subtract the 4, you get 21. So C equals radical 21, which means my focus is H, which is -4. Okay, because I know that from my center. This is H, this is K. Plus or minus radical 21, comma, 3. Okay, so keep it as a simplified radical. We actually can't simplify that radical, so you can leave it like that for paper. So we answered the first part. Now we need to sketch our graph. So let's do that by sketching our center first. So -4, comma 3. We can actually check our endpoints by looking at our major axis. So if it helps you, your major axis is 2A, again minor is 2B. So if our A value is 5, our major axis is 10, meaning I can go 5 to the right, because it's a horizontal ellipse, and 5 to the left. My minor axis is 2 times B, or 4, so I can go 2 up and 2 down. So there is your ellipse. Last thing that you need in there are your foci. So radical 21 doesn't simplify, but it does give you a value in your calculator. So pull out your calc. Radical 21 is about 4.6. So if I take -4 and I add 4.6, I get about, that's right, -0.6, comma 3. And my other foci is if I take -4 and I subtract 4.6, so -8.6, comma 3. Your hint that you're doing it correctly is they should fit inside of your ellipse on either side of your center. Then I can actually graph our first point, which is that -8.6. So I'm going to go over, let's see, 8.6 is like about there. So they're really wide foci. And then if I do -0.6, comma 3, again, it's like really small. There are your foci, okay? And again, they just help you to see that all the values around your ellipse are tethered to those foci and the center at the same time, okay? Next one I want you to do is take your ellipse equation and turn it into standard form. So to do that, it's very much similar to the parabola equation. So see if you can pause the video and try it out yourself. All right, folks, so what's weird about this is you have to do completing the square twice to be able to move everything over. So again, group all of your variables together. So let's do our x squared plus 9, oops, that's not the right one, x squared plus -4x, okay, because those are our x's, and then 9y squared plus 54y, and then it equals -49 because you have to subtract that over. Now, to complete the square, you have to do them separately but add them to both sides. So, the deal with this is we have to keep our x's fine because they don't have anything extra going on. Okay, you can just do that. The thing you have to be careful of is that you're going to have to factor out a 9 from the y's. All right, so you're going to have to then multiply it back through to the other one. All right, so you're gonna have to end up doing, so it'd be plus 9 times y squared plus our 6y, once you factor it out, equals the negative 49. Oops, we're going into that space a little bit, but that's okay. So just be careful, because again, once you factor out a 9, you're gonna have to multiply it through on the other side for the end piece, okay? So complete the square for the x's. So negative 4 divided by 2 is 2, squared is 4. And then 6 divided by 2 is 3, squared is 9. So we're going to add 9 here, equals, I'm going to put it down here, so negative 49. You have to add the 4 from the x's. Then you have to add 81 because of the fact that you're adding 9 to the y's, but you factor out a 9 there, okay? So that ends up giving you 85 minus 49. All right, folks, so you get equals 36, and then you factor what's remaining, so you end up with x minus 2 squared plus 9 times y plus 3 squared. The difference about what we've just done in ellipses, though, is that you can see it equals 1 every time. So that means I need to get rid of that 9 somehow. Easiest way to do that, divide everything by 36, because that'll equal your whole equation to 1. So I'm going to have x minus 2 squared over 36 plus y plus 3 squared over, reduce that fraction, so you're going to end up with 4 in your denominator equals 1. And that way you can figure out your center, you can figure out your a and b values, you can figure out your foci, your lengths of your major and minor axes. So try that out right now. Pause the video, see if you can figure out the rest of that, and then when you are done, I will have the answers for you. All right, folks, so hopefully you got that your a value is 6, because just a reminder that this is a squared, and then this is b squared. So what you end up with is a equals 6 and b equals 2. Okay, and then from there, you can figure out your center, because again, it's your h comma k from here, okay? And then from there, you can figure out your major and minor axis. Just a reminder that your major axis is 2a, which is 12 in this case, and your minor is 2b, so it's 4. You can figure out c from there to see what your foci are going to be by doing a squared equals b squared plus c squared. Again, really close to Pythagorean theorem, but not quite. So from that, you end up with plugging in your a squared is 36, b squared is 4. So you get radical 32, which simplifies to 4 radical 2. Reminder, your foci are your h plus or minus c, comma k. But in this case, remember, it's a horizontal ellipse because, again, your a squared is underneath your x. So that's how you know it's horizontal, okay? You could also, once you find your equation of your foci, which is really this, okay, you can put it in your calculator to get a decimal. You also could technically just go from your center, go to the right 5.7 and left 5.7. If you think about it, that's what you're doing, okay? So your graph looks like this, because your center's here. You go 6 to the right and 6 to the left, because that's A. And then you go 2 up and 2 down, because that's B, to find your vertices. These are called co-vertices at the top and bottom. And then your foci, you can either simplify to find the coordinates or just add and subtract 5.7 from your center. Okay, stay strong. The school year is almost over. Okay, so I would like for you to try this one by yourself if you can. The thing you have to be careful of with is now they're asking you to find the vertices. If you can think about where our vertices are, you're just adding A and B to your center. So just be careful about how you would do that with this case. So for right now, just complete the square, get your equation, and then I can help you if you need to find the foci and vertices from there, but make sure you figure out all the pieces to it. All right, folks, so hopefully you got x plus 1 squared over 4 plus y plus 2 squared over 9 equals 1. If you didn't get that, try to follow along with what I did up top, but be careful. Remember, if you factor out values, you have to multiply them back through. So this was 9 times 1, because that's what you factored out, and that's your b over 2 squared. And you get 16 here because you had a 4 and a 4, okay? This is also going to be a vertical ellipse because, look, our a value is underneath our y. Remember, this is a squared, so this means that a is going to be 3, and b is going to be 2. Okay, so kind of similar to the last one. So take a second, see if you can figure out c to help with your foci. So pause the video, come back, and I'll have it for you. All right, so hopefully you got c equals radical 5, because again, you have to do a squared equals b squared plus c squared. So you get c equals radical 5. That helps you figure out your equations for your foci. So let's find some pieces of information from this. Okay, let's find our center first. Hopefully you already got this part. So your center is going to end up being -1 comma -2. Okay, your major axis is 2 times a again, so it's going to be 6. Minor is 2 times b, so it's 4. Okay, and then again, you have to be careful with your foci here because now it's h comma k plus radical c, or plus c, sorry, and minus c. All right, so now it's going to be -1 comma -2 plus or minus radical 5, which again you can put in your graphing calculator. It comes out to about -1 comma 0.24 and -1 comma -4.24. Okay, so that means we are good to graph. Sometimes it's easier to figure out your vertices by graphing first, or just think about it. So if our center is at -1, -2, -1, -2, and then our major axis is 6. What that means is you are going 3 in either direction vertically, right? So you have to go 3 above and 3 below. Those are your vertices. Okay, so the easiest way to think about it is you're going to keep your x value for your center, but you're going to take your y value and you're going to add and subtract a. So it's -2 plus or minus 3, if you think about that. So then we get -1 comma 1 and -1 comma -5. Those are your vertices. If they asked you for co-vertices, that would be where your b values come from. So you would go 2 to the right, 2 to the left. That's your vertical ellipse. It's pretty small, but that's okay. And then you can grab your graph your foci from there. So they're really close to each of those vertices, which usually happens. All right, the bottom one I want you to see if you can try by yourself. Give it a second. See if you can figure out, first of all, where they got the b from, because they didn't give you that in the original question. They just said you have foci at 0, 1, and 4, 1. And then your major axis is 6. I'll give you a little hint if you're not sure. If your major axis is 6, that means a has to be 3. Okay, so pause the video, try it out, see if you can get it. Okay, so from there, what I recommend doing with these is graphing it like they did. So if you graph your foci at 0, 1, and 4, 1, how do they get 2, 1 for your center? It's because that's halfway between 0, 1, and 4, 1, so you can just count. It also means that your c value is the distance between your center and one of those points. So if you counted, your c has to be 2. We have a equals 3, c equals 2. So from that you get to figure out what b is, because remember, c squared plus b squared equals a squared in this case. So if I have a squared, it's 9, c squared is 4, So b equals radical 5, like they said. So from there, it says find the standard form. You already have your center. You already have your a and b now. You know it has to be 1. And you know it's going to be x minus 2 because our h is 2. And it's going to be y minus 1 because our k is 1. And then you just have to divide by your a and b. If it's a horizontal ellipse, I can tell that because my foci are next to each other, then I know I'm going to have a squared underneath this part. So a squared in this case is 9 because it's 3 squared. B squared goes underneath the second part, which if you square radical 5, you just get 5. So there is your equation. Alright guys, least is the back. This is an application of ellipses. So an elliptical orbit is an example of this. I'm going to have you read through the problem on your own and then let me know at another time if you need my help figuring out what it is. Have a great rest of your day.